Hello everyone. We are going to transform another graph. This time we're going to be transforming the cube root graph. Now the cube root graph can be a little bit frustrating to draw, so we'll just do our best. And the original cube root graph, looks something like this. So we'll just see what we can do. In order to do a transformation of the cube root graph, we need to list some ordered pairs that are on the original cube root graph. These are sometimes the hardest ones for people to remember. But the best ones are -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. Now we need to figure out how we're going to change each one of these ordered pairs. This -1 is going to do something, this +2 is going to do something, this minus sign is going to do something, and this 3 in front is going to do something. Well, the -1 at the end is going to shift the whole graph down 1 unit. We take care of that by subtract 1 from y. The +2 on the inside is going to shift the whole graph to the left 2 units. That's the backwards one. And we're going to do that by subtract 2 from x. The minus sign that you see directly in front of the x is going to reflect our whole graph over the y-axis. We can accomplish that by changing the sign on x or multiply x by -1. The 3 out in front does not cause a reflection. It does cause a vertical stretch by a factor of 3. That is accomplished by multiply y by 3. We've got 4 things to do. Horizontal shift first, vertical shift last. Finish with the x's before we start the y's. All right, let's rumble. 1, 2, 3, 4. First step, let's subtract 2 from every x value and leave the y's alone. -10, -2, -3, -1, -2, 0, -1, 1, 6, 2. I subtracted 2 from every x, but I left all the y's alone. Now I'm supposed to multiply all the x's by -1 and leave the y's alone. 10, -2, 3, -1, 2, 0, 1, 1, -6, 2. I just multiplied every x by -1, changed its sign, but I left all the y values alone on that step. Now it is time to start messing with the y's. So we will multiply all the y's by 3, but leave the x values alone. 10, -6, 3, -3, 2, 0. Didn't change. That's okay, because we multiplied 3 by 0. 1, 3, and -6, 6. Okay, final thing to get our ordered pairs that we're going to need to graph is we're going to subtract 1 from every y value, then we'll be ready to go to graph. Here we go, leaving the x's alone and subtracting 1 from every y. Leaving the x's alone and subtracting 1 from every y. It's so easy to make a mistake when you do these, just a small arithmetic error, that if you have extra time, you should always take some of these x values from this final row, plug them into this original f of x function, the transform function, and see if you get the y value we claim we're going to get. So just try it. Take one of the x values like 10, plug it into the f of x function, and make sure you get a -7. Once you've checked that, you're ready to go to the graph. So scroll down here so we can see our graph, get our ordered pairs up there. 10. -7 is going to be my first ordered pair. All right. So 10's all the way to the right here. 1, 2, 3, 4, 5, 6, 7. Wow, way down there. Okay, 3, -4. 1, 2, 3, down 4. 2, -1. Got it right there. Can't really see those very well. Sorry about that. 1, 2. And -6, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. All right, now this is the cube root of x graph, but it's been stretched out by a factor of 3. So it's going to be kind of hard to sketch this, but we'll do our best. There we go. Yeah, it's been reflected, it's been shifted, it's been stretched, but that's still the cube root of x graph. Did I say x cubed before? I'm sorry. This is the cube root graph. You'll notice this point right in the middle, 2, -1. That's the point that's right in the middle because it's the point that we got from 0, 0. Hey, the original cube root of x graph has a domain and range of negative infinity to infinity, so does this. So domain and range, negative infinity to infinity. Those are a pain to draw, but just do your best. Hope that helped. Thanks for watching.